In example 2, we want to state how many solutions each system has. We actually have 3 to do here, A, B, and C. So let's start off with our substitution, and I'm seeing that the x here is solved for, so we're going to replace this x with negative 2y plus 4. So if we do that, we can use the distributive property after this, and we've got negative 4y plus 8 plus 4y is equal to 8. Negative 4y and 4y is 0, and we get this weird looking statement that 8 is equal to 8. What happens when you're trying to solve for a variable sometimes is that the variable will go away. You're left with either a true or a false statement. This one happens to be true. What that means in terms of a system of equations is that there is an infinitely many number of solutions. So we usually write infinitely many. And the thing here is that these two lines are actually the same line. And so whatever point works for one, or whatever x comma y works for one of them, it's going to work for the other one as well, because they're the same line. And because there's an infinitely many number of points that make up a line, and if those points automatically work for the next one, there's also an infinitely many number of solutions to this system. Let's try the next one. This time, we're going to take the y out right here, and replace it with 3x minus 11. So we'll have 3x minus 11. I'm not even going to use parentheses because there's no coefficient here. You could if you wanted to. And the negative 3x and the positive 3x cancels. We get negative 11 is equal to negative 13. Well, the variable went away again. And so when this happens, we're going to look at the statement that we get. And this one happens to be false. And this means that there is no solution. Graphically, if you graph these two lines, they would have the same slope but different y-intercepts. You can imagine just adding 3x here. You get y is equal to 3x minus 13. You can see they have the same slope, but their y-intercepts are different. And that means that they're parallel. And then if one point works for one, it won't work for the other one. There's no point of intersection at all between those two. Let's try this last one. Here we're going to take the y out. We have a negative sign, so we're going to have to deal with that. And we're going to distribute that, and you can think about it like a negative 1 if you want. So negative 1 times 5x is negative 5x, negative 1 times 6 is negative 6. 5x minus 5x is 0, and negative 6 is equal to 6 is a false statement. And so this one will be no solution for sure.